All right. Good morning, everyone. Actually, we're very glad you're here this early in the morning. Thank you so much. My name is Kundana Palagiri. I'm a program manager in the Azure Compute team. With me is Michael, who's going to talk about Chef. Michael, do you want to?
Yep, I'm Michael Ducey. I'm a global evangelist for Chef. If you have any questions afterwards, you can, of course, find us here. But also, after you leave, if you have any questions, feel free to reach me on Twitter. @MFDII is my handle.
Cool. So before we start, a quick show of hands. How many of you are already using Chef somewhere and want to use an Azure? Cool. How many of you are here to learn about Chef? I've heard about Chef and want to learn about Chef. Oh, wow. I think this is a great session for that.
That's great.
Yeah. And the last one, how many of you manage only Windows virtual machines? And how many of you do the mix Windows and Linux? Oh, great. So we have the perfect title, actually. Is there anyone just doing Linux? Just doing Linux?
Wow, one.
Just Linux, yeah.
Just Linux.
Yeah.
Okay, that's actually great to know. So the takeaways from this session, we want you to walk away with this. We want you to get a good grip of the Chef concepts and all the information to get started with using Chef, and how you can manage Windows and Linux workloads in Azure using Chef. And finally, we'll after introducing some of the concepts, we'll actually show you the end-to-end scenarios of how this works. So the bottom line would be, you will walk away. We want you to walk away with all the information that you need to get started.
And so this is a deep dive session as advertised, but it's actually going to be more of instead of going deep, we're going to go extremely broad. So I guess that's one form of deep, depending upon how you look at it. So let me talk about the Chef platform real quick. So just so you understand some of the terminology and ideas and concepts when you're interacting with the Chef ecosystem. So the Chef platform pretty much looks like this. It's a server-based system. So there is a centralized server called the Chef server. That Chef server talks to what we call nodes. And if you think of what a node is just an operating system that's under management. So an instance in Azure, an instance in your own data center, an instance in another cloud provider, and so forth. Then cookbook authoring and policy authoring are done in what's called the Chef development kit. So this is basically where you guys and ladies do the administration work to actually go and program how you want your systems actually set up. And I'll show you how you actually write that language to make those systems get set up. And there's also a whole other set of toolkit that we're not actually going to talk about today in the Chef development kit that helps you do cool things like what we call test-driven development for infrastructure or test-driven infrastructure. They also have a management console, an analytics platform, and some other things that plug into the Chef server that give you some additional information about what's actually going on in your environment and all the nodes that are actually running what pieces of recipes and so forth.
Cool. So, so before we actually deep dive into Chef, let's look at some of the DevOps principles that we use in Azure, because everything that we see in the next 30-40 minutes is actually very tied to these concepts. So, Azure is on a path of supporting a growing list of tools and technologies for DevOps. This is a point-in-time snapshot, but this is a growing list, and we would be continuing to invest to provide a seamless experience for not only first-party solutions, but third-party solutions as well. And one of the very fundamental concepts that we will be using for the rest of the session, and even when you go back and when you try out these things, is the Azure Resource Manager. How many of you have been in the resource group sessions the last couple of days? Cool. A few of you. So if not, I would actually encourage you to attend the reruns or view the sessions online, because going forward, everything we do in Azure is actually built on these concepts. These are the fundamental concepts that would be using again and again. So previously, if you have already used Azure virtual machines, you know that when you create virtual machines networks, it's up to you to connect them all together. Azure Resource Manager actually changes all of that. It introduces the concept of grouping resources together. So a resource group is a container of one or many homogeneous or heterogeneous resources. So these resources, are being instantiated by the Azure Resource Group, which is actually a fully extensible model. So we have all the resources that are available in platform are supported by Azure Resource Manager, and it's an extensible model. So we have onboarded new partners already, and any new partners that come into the platform does not require changes to the resource manager itself. We have an onboarding process. We can onboard new resources. So what you get with this grouping is a support lifecycle that's tied to all the resources in the resource manager. So you can actually use single APIs to perform lifecycle operations like update, delete status. You can scale up, scale down for these resource instances. And the really nice thing with this, what you get is these resource APIs are actually backed by a declarative JSON model. So you can define your infrastructure, which we'll look at it in a demo today. You'll define your infrastructure using a JSON template, and you will use Azure Resource Manager to instantiate that. So as an example here, here's I've defined an application which has a SQL website and virtual machine instances, and I can define the dependencies between them. And at this point, Azure Resource Manager is responsible for orchestration of this resource creation in Azure. And you can also set, because you've set dependencies, and it also supports parameterization. What that means is you can take the same template, you can run it in your dev, test, staging, production, whichever environment, based on, and supply a different input parameter. And because this is JSON files, this can be checked into into any source repository, and then finally these templates that we have. We've started with a few templates in GitHub. It's available in Azure.com. These we are really hoping that the community contributes as well, so they can take these base templates. You can customize it and you can share it. So very powerful way of doing DevOps in Azure. The next fundamental concept that we will be using a lot in addition to the templates is the extension model. This is again very unique to Azure. So what it does is today, if you want to provision a virtual machine in Azure, you can do it from REST APIs, you can do it from Portal, or you can use it from Azure CLI, and you can actually do it from Knife as well, which is the command line tool from Chef. So you can use any of these tools to provision your virtual machines in Azure. Once they're provisioned in Azure using our extension technology, we can inject the Chef agent into a virtual machine. This virtual machine can be a running virtual machine which was created a while ago, or it's a brand new VM that was just provisioned. So this extension technology actually, we have a set of curated extensions and that you can pick from, or you can write your own scripts that you want to inject into the virtual machine using the extension technology. So templates, extensions, a combination of these two is what we will be using again and again for showing some of the Chef integration with Azure. All right. So with that background in mind, let's move on to what are the various integration and what are the various integration hooks that we have provided for Chef. So we've been working with Chef pretty closely for the last 1 year, and we have enabled quite a few scenarios there. So if you look at these, okay. So these are some of the things that you can do with Chef on Azure. In this talk, though, we will not be getting into the details of everything. We will cover a few of these. We'll actually do a deep dive of a few of these. But if we haven't covered anything here and that's of interest to you, please stop by after the talk, and we can actually show how you can do many of these. The first purple box that we'll double click on is the Chef server. So as Michael mentioned earlier, right? So if you are setting up your Chef environment, the core piece there is your Chef server that is going to manage your nodes. There are a few options for setting up Chef server. The first one is, you could set it up on-prem. You can get a Chef license and you can host your Chef server on your data center. And then you have the hosted Chef option, actually, which is a really great way to get started. You can go sign up for a Chef account. You get a certain number of free nodes. This is all managed by Chef. And the third one is also a very easy to get started option is having a Chef server, getting the Chef server from Azure Marketplace. Let's look at that, what that option here is. So before we do that, I want to quickly show the Azure Marketplace. So, Azure Marketplace has been around for more than a year, and what it provides today is a set of end-to-end solutions that the third-party publishers have provided for Azure customers. These actually, they go through a certification process, so you know that it comes with a certain amount of validation. And then the really neat thing about it is you get a consistent experience for deploying any of these solutions on Azure, and you also get an integrated billing support for this. So Chef Server is part of the Microsoft Azure Marketplace offering. If you have set up Chef Server in Azure, you know that there are a few steps involved, and this actually really simplifies its deploying of Chef Server in Azure. And this is really a great option where if you want to get started with Chef Server and you want all of your data to actually reside in your regions that you've selected your virtual machines, this is a really good option to get started. This also comes with a certain number of free nodes, like 20 nodes?
25.
25 nodes, okay. So, when you get this Chef Server image up to 25 nodes, you can connect 25 nodes and play with it. This is a single command to actually get a fully working Chef Server in Azure.
And the one note I'll add is also if you download the on-premise version, it's for up to 25 nodes for free as well. And then there's also some open source components to that as well, to where if you just use the open source components, you can use it for up to, n number of nodes, where n is a very large number because it's open source. So let's talk about Chef and what Chef actually does for you and means, and let's start to get into some of the details of Chef. So let's talk first about how we used to do traditional systems management. So you'd have a configuration. Does this look familiar to anyone? You have a configuration you'd get from some place, and then you would take it, a person takes it, and then logs into all the machines, RDPs or SSHs. If you get really fancy, you'll put an SSH in a loop, right? And then makes you like power admin, right? And you can do a bunch of stuff very quickly across a number of machines. And then we had automation come into the picture, right? So the loop I just talked about is a form of automation, right? And then we had other tools that came about that was really just taking this idea of a configuration and how do I take a configuration and apply it to a machine, right? Well, as most of you know, we're not actually deploying configurations. If you look at things at a more macro level, what we're actually deploying is a service. So something that provides value to the end user or provides value to the business, right? That service is actually composed of different configurations. And so you want to package up those configurations into some sort of a package that you can then take and then apply to all the different machines that you want to have running that particular service. So think of services of things like a web server service to run a particular application, the back-end application server to run a particular application, a database service, and so forth, right? So it gets a little bit more complicated then when you want to take this service and be able to deploy it across many different regions or many different clouds, or you want to do on-premise and you want to do maybe Azure as well, or as we call it, hybrid cloud, right? So it gets very difficult to do that if you're just pushing configurations around. If you have your services and configurations abstracted away in a language that can be done programmatically, it's much easier to then take that service and push that service around to all of the different cloud instances that you might have running or on-premise instances and so forth. And so Chef helps you with a couple building blocks. There it is. Like I hate being behind the podium and clicking the keyboard, so I have my clicker now. So let's talk about the basic building blocks of Chef. Once we talk about the basic building blocks of Chef, I'll talk about some Windows-specific things. So the two people who only manage Linux machines, you can take that time to maybe take a nap. And then From there, good, I finally got a laugh out of some people. We're starting to wake up, right? I need everyone to stand up, and we're going to do jumping jacks and a stretch real quick. No, I'm joking. So let's talk about these building blocks. So at the most basic level there's what's called a resource in Chef. And so a resource is just a state of a component of the system that you define, right? So you want a package installed or a Windows feature installed. You want a service to be running, right? You want a file in a certain location with a certain permissions, and you want maybe certain content in that file as well, right? So these are all states of the system that we're defining. And so you declare that state, and Chef always makes sure that that state is achieved. So if you've heard about desired state configuration in PowerShell works on the exact same concept. You define the state, and the DSC agent actually figures out how to apply that state to the system, right? Chef works the exact same way. We figure out, you just tell us how you want it, you tell us the state you want it in, and we figure out how to achieve that state, okay? So an example of a state in the Windows world is I have a Windows feature that's called web server, and I want to ensure that it's present, right? Pretty basic, pretty simple, pretty easy to understand. In the Linux world, you could say I want a package called HTTPD, which is Apache in most distributions, and I want to make sure that it's installed, right? So pretty basic, pretty easy to understand. So let's talk about what recipes are. So Chef has this concept of recipes. Recipes are essentially just a collection of resources to deliver a service, right? So I could have that resource that I just showed, but all I'm doing is actually installing software. I'm not actually doing anything useful. I don't have a service yet that I can deliver. Why? Because I haven't put any configurations in place to make that service actually something useful. A key point is that that resources are executed in the order that they appear in the recipe, okay? So if you say, I want the web server turned on, and then I'm going to install the web server, it's probably going to fail, at least the first time. The second time, it might succeed because it might have installed that. Or actually, it probably will never work. Reverse that. Because it'll always fail on the service, so it will never get to the point where it's installing the actual package that you need. So you want the package to get installed first, then you want the services turned on, right? Makes sense. So let's look at an example in the Linux world. So this is a little bit more of a complete service in this case. So I have my Apache package that I'm installing. I'm going to include another recipe that enables me to turn on firewall or open firewall ports. And then I'm going to enable and start the service. So every time that the machine boots up, Apache is going to start, and I'm going to make sure that when this runs, I'm going to make sure that I've actually started Apache. So now I actually have a web server that will at least, in the basic case, serve a default website. And if we look at this for Windows, it's a little bit more lines, but it's not necessarily much more complicated. So we include I'll actually show this recipe later. So I include this recipe called Fourth Coffee DSC, which will install the web server components that I need. I also remove the default site as well, because we don't need the default sites anymore. And then I'm going to put some code in place. I'll talk about this later, so I'm actually going to, if this doesn't make sense right now, I'm going to dive into these elements during the demo. And then I'm going to create an IIS pool. I'm going to add it. And then I'm going to create an IIS site, and it points to this install path, right? And I'm going to add it, and I'm going to start it, right? So pretty simple, right? So we take recipes, and of course, what do you put recipes in? Cookbooks, right? So a recipe is essentially just another higher level abstraction of a service. So you might have multiple recipes. In this case, I don't. I was looking in the wrong directory. So you could have multiple recipes because maybe you have different components that you want to turn on and turn off of the particular web server that you're installing or the application that you're installing. So a good example is if you've ever administered an Apache web server, you have all those modules that you want to turn on and turn off in Apache. So you could have a recipe for each one of those modules to turn on and off those modules, right? The other key thing is that recipes include what's called attributes. And I'm going to dive into attributes a little bit deeper, but let me give you a really basic example of an attribute. So it's basically the data elements that you need to make intelligent decisions or make intelligent configurations inside of your recipes. So you saw earlier, I was at this conference once and I was speaking, and like this thing wouldn't work unless I went like this. Like I would try and click and it wouldn't work, and like every time I went like this, it would work. So if you see me doing this, that's why I'm doing that, because it appears to work. I don't know. It must be these Kensington ones. So this is an attribute. I've defined an attribute for the port that I want the Fourth Coffee web server to be listening on. I've defined it. Now let me actually consume it. So you notice now, instead of hard coding port 80 in my recipe, I can then have a variable here that I'm just referencing. So that's what this install path actually does, because my install path might be different depending upon where I'm actually deploying this. So if I'm deploying it in production, it might be one install path. If I'm deploying it in development, it could be another install path. If I'm deploying to one environment versus the other, the port might be different. Or if somebody else wants to consume this and they don't want to have to change the actual code that I've written here, then all they have to do is change the attribute. They don't actually have to change the how, right? They can just change the data that's passed into the how, right? So it makes it a little bit more easier to consume cookbooks and recipes when you have attributes that people can easily change.
So Michael, the recipes are same across all Linux distros, right? I don't have to like rewrite a recipe for multiple.
Well, that's a good question. So when you saw the recipe here, so generally speaking, this will work for most Linux distributions. The only thing is that the name is different depending upon what Linux distribution you're running on. So Chef has the ability to where you can actually write a case statement to make a decision to say, if I'm running on a Debian-based system, install Apache. If I'm running on a Red Hat-based system, install HTTPD, because the package name is different. So this actually has to reflect what the actual underlying package manager knows about. Same thing for this as well. The service name is different depending upon what distribution you're running on. But Chef provides attributes, which I'll actually show later, that actually enables you to make intelligent decisions directly in your recipe depending upon what platform you're running on. So you could have this one recipe that could work cross-distribution, and there's a lot of recipes that we have out there that actually do that for you.
Is questions in between okay?
Huh?
Asking questions in between okay?
Yeah, you can. If you have a question, feel free to interrupt and ask a question. There are microphones as well that it might make it easier.
Thank you.
Okay, so let's talk about Chef and DSC. So you noticed that I was using DSC to actually install that Windows feature earlier. So we have a booth here, booth 236. Had to get the plug-in. So we have a booth here, and we've been getting lots of questions of what is Chef, but then also, how is Chef different than DSC, right? So the way Jeffrey Snover describes DSC is it's essentially the printer driver, right? So it's basically the printer driver for easily automating Windows. So it's an API into the operating system. So it makes it so much easier for us as an automation company to then interact with the operating system, because we don't have to wrap Windows commands anymore. I actually have that on the next slide. I thought it was on this slide, so I'm like confused about where my slides are. Sorry. So we don't have to wrap Windows commands anymore. We don't have to write PowerShell scripts anymore and wrap it with a bunch of checks and guards to make sure, because you don't want to install the feature if the feature's already installed. Well, DSC lets us just write the DSC document and say, okay, DSC, you figure out if it's installed or not. So it makes it really easy for us to interact with the operating system. It's a common interface into the operating system and an API that we can write against. And the other thing is we don't have to parse. Like if anybody's written any automation on their own before, you know it's really a pain in the butt to have to parse command line output, because most command line output, especially in the Windows world, was designed for a human to read it, not for a machine to read it, right? So it's very hard to parse and it's not machine readable. So an example in the DSC world, I want to ensure that this archive is present. This is where you get the archive from, and this is where I actually am going to extract it. So this is what it looks like in DSC. If I look at the exact same thing in Chef, it looks very, very similar, right? But now I can also do things, if I'm a Windows admin or I'm a Linux admin, I'm now writing things in the same language, right? And it can be all in the Chef language. And then Chef provides a framework around a lot of things as well to help you manage multiple machines across multiple data centers and so forth, right?
So Chef is doing the translation from...
So Chef would do the translation. So what Chef will actually do is translate this into this, and then send it to the PowerShell or the DSC agent, and the DSC agent will apply this, right? So it makes it a lot easier for us because we just have to write this document. Question?
Now that DSC is available on Linux, what does Chef offer on top of that now? Want to use straight DSC?
That's what I'm going to talk about. Yeah, thank you. So the question is now that DSC is available on Linux, what does Chef offer on top of DSC on Linux, right? So what you need is a framework to actually manage all of the systems, right? So it's great that we have DSC, but how do you get those state changes out to the system, right? Yes?
Can I add to that, how do you make decisions of what you do in Chef versus DSC?
Well, I have a biased opinion, so I'm going to say you should do everything in Chef, right? And there's also things that we deliver around an analytics stream to actually see what state changes on the system. There's also a lot of compliance rules that we can write in about that analytics stream. You can then take that data and pump it into other log resources and other things like that as well. There's environments and roles and other things that I'm going to talk about here shortly that give you an overall framework that makes it easier to make those changes onto systems.
Yeah, I think you can use both. It depends on, if you want to use the higher level services that Chef provides, it makes a lot of sense to actually use that as well. Yeah.
So as I said, Chef provides a framework, and then DSC provides the actual path into the operating system to make the changes. All right, so let's go back to the building blocks. So 2 more building blocks. We have roles and environments. So I kind of touched on environments and roles here a little bit already. So let's look at a role. So when we think of a server, we don't necessarily think of a server as just a server. What do we think of the server? We think of a print server, a file server, a web server, a database server. We think of the role that that server provides in the organization or in the application stack, right? So here we have a role for a Fourth Coffee web server. It's going to include the Fourth Coffee recipe that we showed already. And then it's also going to install this base Windows configuration. So if I have basically every single machine should always have this base level configuration, right? Everybody's got it, right? It's at the front of your standard operating procedure when you're provisioning a machine. It's all the things that you have to set up to make sure everything's going to work properly or that security team is going to be happy. It's all the agents that you want to have installed for monitoring and so forth. That would go in a base recipe. And every single time that I apply this Fourth Coffee role, these 2 recipes will get executed in order. So I always know that my base Windows configuration will be there, and I always know that my Fourth Coffee web server is going to be there. So I don't, instead of having to apply these 2 recipes myself, I can just apply the role and then let Chef figure it out. The other thing that you can do is attributes. You can change attributes. So if I wanted to change that port that we saw earlier in the recipe, I can actually change it in the role, and I don't actually have to go and change my recipe. I can change it in the role, and this value will end up getting passed down into the recipe, right? So it makes it easier to make those kind of switches and changes that you want to make without having to change my actual infrastructure code itself. And then there's the concept of environments. So environments kind of take it a step further and think of environments to where the environment where the nodes live in, right? So you have a lot of nodes. Some nodes are dev, some nodes are test, some nodes are production, right? So those are environments. It could be Bob's servers that he plays around with, or test lab would be a more appropriate name instead of Bob's servers. But But what you can do is, for certain environments, you can pin cookbook versions. So I'll talk about versioning here in a second. But basically, you can have different versions of cookbooks living in your environment. And so this is one of the things that Chef adds on top of just traditional DSC. So I could have production being pinned to a certain environment, and then my dev and test and staging might be on a completely different environment because I'm moving changes through the systems, and I want to move those changes through, but I don't want to infect production with code that we don't think is ready, right? The other thing is you can override ports as well. So this port will end up going down into the recipe, and instead of the web server listening on port 81, or I'm sorry, on port 80, it's going to listen on port 81. So let's talk about the last building block. The last building block is data bags. So data bags are basically global variables that you can access from all the things, right? So it's basically just a JSON-based data store that you can store information in and query that information out. You can also encrypt that data and store that data encrypted at rest, and then when the machine needs it, it would download that encrypted data, decrypt it with its own key, and then use that data, and then that data actually doesn't stay on the machine anymore. It's in memory at that time, and then once that Chef run has completed, it'll go away, and then it's stored at rest on the server side again. So a good example of how to use this is something like if you have different versions of applications. So in development, we're going to have my app with version 1.1.0, and the dependent app is going to be 1.2.1. So in production, I might have a completely different file with only version 1 of my app. And so as I'm doing kind of a multi-tiered deployment, I can actually specify the multiple tiers in here. And this is just arbitrary JSON data, so you can actually structure this any way that it makes sense for you. And then you can actually do like rolling deploys and pushing things out through an entire application stack. So let's talk about Chef and versioning. So so let's talk about two problems. So different instances need different versions of applications or cookbooks, so what I just kind of showed. And so then how do you perform a rolling deploy of new application code or cookbooks out to your environment without breaking things? So I've kind of already given away, but let's dive down a little bit more into versioning. So cookbooks are versioned. So every cookbook that you store on the Chef server itself will have a version number. You can bump that version, and then the nice thing is when you bump that version, other people can know whether or not if they should be using it, because then they can create dependencies. So remember in that example where I was actually pulling in a recipe from another cookbook, I could actually take that other recipe, that include recipe statement that I had, I could actually say that I want a certain version because I depend on that, and I want to make sure that I'm locked to a certain version of that recipe so I don't get changes that other people have pushed upstream and break how my infrastructure code works. And then the other thing is versioning allows different environments to use different cookbooks, depending upon what you actually need to achieve in that environment. So example, as I showed earlier, so in my development environment, I've got Fourth Coffee version 2.2.1. But in production, I have 2.2.0. So production will never get any other version of the cookbook except 2.2.0. And until I go and bump this number when I'm ready to do a release, when I'm ready to push changes, I can go and bump this number in my environment file, have Chef Client run on all my nodes that run that application, and then I can know that I've deployed that application out to all those machines. If I'm not ready to do it, then I just keep this locked, and I can prevent development changes from going out into production before they're ready. And then the other thing is that attributes can be used for application versioning as well. So you could have an attribute to say, okay, I have a release version. So for this particular Fourth Coffee site, I could hard code that in my attributes file, much like I did my port. And then the other thing is I could use data bags for application versioning, which I've already kind of talked about that. So using attributes, you've actually now used cookbook attributes, but you aren't able to kind of link together the dependent applications. Because in your cookbook, you shouldn't necessarily store application versions of other cookbooks and things like that. Now you can link dependencies in your dependency listing, but what you actually want to try and do is extract that data out from the cookbooks themselves, because remember, the cookbook is the how, and then the data should be removed. And data bags allow you to remove that data out of the actual how or the actual code, and then query that data when you need that data, because you might actually need this data in another place as well. And putting them in a data bag allows you to then have it searchable and queryable. So you could have dev with these versions of the applications, and then in production, we're going to be on 1.0.9 and 1.2.0. And every cookbook that would query this then, or recipe that would query this, and they would say, okay, what version of the jar do I need to download? Or what version of my application code do I need to download? Well, I always download 1.2.0, always download 1.0.9. When you're ready to bump production into the next version, you can just go in and change this version number, upload the data bag, and then all those machines that actually depend on this data will then get updated. Make sense? So let's talk about attributes and search. So I touched on attributes very briefly, but let's talk about a little bit more in detail in attributes. So there are lots of attributes of a system. So we have a collection system called OHI. And OHI, what OHI does is it basically scans a system at runtime, and it goes and looks at all of the attributes of the system, and it collects all of that information of who a server is and stores it in Chef. So it pushes that data up, and then that data is indexed, and then it's also searchable as well. So to give you an example, so you notice here, ignore that where it says Windows hacks. But like, here's some data that we've discovered. So IIS, right? We have where the home is, the pub root, the doc root, and so forth. The logging directory, what components are installed. You can see here from the recipe that I injected the install path for Fourth Coffee as well. Now, some other automatic data that we collect. So here's the kernel. So what operating system, what build of the kernel that I'm running, machine info, so what platform I'm running on or what architecture I'm running on. You also notice down here, platform and platform family. So if I was running on a Linux-based machine, this platform would be Red Hat or Debian or something like that, right? And then I can also get the version of the operating system, IP addresses, all of these details that sysadmins care about, right? So the nice thing is that I can search this data. And when you have a multi-tiered application with other components that are dependent upon one another, you might want to be able to build out some sort of a topology or information about how those things interact with one another. So remember I said the data is stored and indexed, and you can query that data not only from the command line or from our user interface, but you can also query that data from recipes as well. So let's say I have a load balancer, an HA proxy load balancer. It's an open source load balancing software program if you're not sure what it is. It's pretty cool. You should check it out. It's really good for very easy building of load balancers, right? So you search for all my nodes, so all my instances, and I want to search for all the instances that are running the role Fourth Coffee web server, right? And we showed the Fourth Coffee web server role earlier. And then I'm going to take this search result, and I'm just going to store it in this variable here. And then I take this variable, and I just pass it into the HA proxy configuration file. And then this configuration file will take this information and then build out my configuration file, or my configuration file dynamically every time that this runs. So in an environment where I'm scaling up and down, and I might have 10 web servers one day, I might have 20 web servers the next, I might have 5 depending upon application load, I can actually dynamically scale up and down this configuration file, and the load balancer will have the right number of nodes in its configuration file whenever it runs. So that's search. So it gives you this powerful ability to actually go out and create multi-tiered applications inside of your recipes. So let's talk more about, I think this slide is totally in the wrong place. So I've been using Office 2016 Preview on my Mac, and it does these weird things when I'm like dragging things around, and I think this got dragged in the wrong place. So that's why you should never use beta software for production needs. But by the way, like that, it's actually night and day better than the old version. So they've done a great job. I'm just ready for it to be production ready. Thank you, Office team. All right, so let's talk about Chef provisioning real quick. So I've talked about how you set up bits on an operating system that already exists. How do I get that operating system or that machine to actually exist in the first place? And Chef has a couple different ways that you can do it. And there's a couple different ways in the Azure and Chef ecosystem that you could do it. So you could use Azure CLI. You can use Knife. So we have a command line utility called Knife, and you could create a server through that. Or you could do it more programmatically because you might have multiple servers that you want to actually create at one time. So there's this tool called Chef Provisioning that allows you to do that. So it's programmatic access to instances, and it allows you to create complete service stacks. So an example is say, I need 3 web servers, so from 0 to 2, so that's 3. I'm going to create machines that are called Webinar Web, and then this value will get substituted in here. So I'm going to have 3 machines, Web 0, Web 1, and Web 2, and it's going to get the 4th Coffee web server role. So this will actually go out to Azure and provision these machines for me, and then once the machines are provisioned, it will also then do a Chef run to actually install the 4th Coffee web server. It'll also do all of these machines at the exact same time, because I'm saying that I want to batch these machines together up into one request and to do all of them in parallel, right? If I didn't have this in batch, what's going to happen is it'll create 0, it'll create 1, and then it'll create 2. And then at the end, I can then go and create my load balancer. Since the load balancer is dependent upon the web servers, and my web servers need to be created before I can create the load balancer, I then, outside of this batch, I go and create another machine. But you notice that we're using the exact same language that I used to describe a package to be installed or a Windows feature to be installed. So I have a resource. The name of the resource is machine, or the type of the resource is machine. The name is Webinar Load Balancer. And then I have some attributes that I'm going to pass into it. This is question.
What happens if it fails?
That's a good question. So in any recipe that if it fails, it's going, so if it fails here, if it fails on 0 or it fails on 1 or if it fails on 2, it's going to stop right there. And then it won't create Webinar Load Balancer at all. So wherever it stops is where it stops, and it's not going to continue to run the rest of the recipe. You can have what's called exception handlers to get alerts to have notifications that this run actually failed. But this is great because you could actually write something like this that describes how the application stack should be set up. You can give it to a developer who's maybe doing development work on this 4th Coffee website, and you can say, here's the command that you need to run to stand up your dev environment to actually test your code to make sure it's actually going to work. Or you could feed this into something like a continuous integration pipeline to have something like Jenkins or even Visual Studio or another tool or something like that stand up the application stack, deploy the code, verify that it actually works, and then tear it down afterwards, right? So it gives like programmatic access to the infrastructure to developers, sysadmins, other people within your organization very easily and very quickly.
So one of the things I want to add is Chef provisioning. If you look at it, it's actually a whole lot similar like what Azure Resource Manager does. In fact, some of our customers who have used Chef provisioning and Azure Resource Manager have said that, hey, they do the same thing. In fact, they should be working together. And actually, that's what we would be doing. We think it's really powerful if you can write a template that can work on-prem or in Azure, and you can use Azure Resource Manager or Chef provisioning to provision that infrastructure.
Yeah, so that's a good point. So this, you notice I never specified what cloud environment or what infrastructure that I'm actually going to point this at. I've left out all the configuration bits of that, but there's many different what we call drivers to actually use this either on-prem or use it in various cloud providers. Azure is definitely one of them. So if you wanted to take this and be able to port this to on-prem or Azure or a different region, it's actually really, really easy to do You just have some configuration bits at the top to say, oh, I'm going to use that other cloud provider, or an on-prem cloud, or vSphere, or I'm trying not to say names I'm not supposed to say. Is that okay?
Azure Stack.
Oh, Azure Stack. Thank you. Only thing I can think of is like all of your competitors, right?
All opinions.
But if you wanted to move from a different cloud provider to Azure, like if you define it like this, it makes it really easy to do if you define things programmatically. All right, so some things that we're going to be adding in Chef provisioning to make it more awesome. So we want to add in more Azure services. And we also want to add in support for Resource Manager. These things are actually being worked on right now by a great community member. His name's Stuart Preston. If you Google Stuart Preston Azure, he's got a great blog where he writes about how to use Chef and Azure together. And then he's also contributing a lot of code as well to actually make these things work. So big shout out to Stuart and all of the work that he's doing there. Okay, so let's pull it all together. So remember when I showed this diagram earlier? So we have a service, we have automation, we push it out to various regions of Azure or on-prem. And then what we actually think of when we think of this, we just don't have one service in our stack. We actually have a picture that looks probably a little bit more like this. We have multiple services. There's dependencies between them. So remember, I had the the load balancer searching about the web servers. Recipes can be used across different roles as well and different nodes. So then you take these services and then you can use them as building blocks to deploy the application, and you can use them over and over and over again. You have different versions of them as well. The nice thing is then if you think about it, it's much easier to take the way your infrastructure looks and then move it into different cloud environments and so forth. I always hate it when you see like something like this where it didn't wrap right, and you swore that it wrapped right when you submitted it. I think all your changes, you might have messed that up.
It's not. You were the one who was changing last minute.
Oh, now it's my fault because I made changes this morning.
Yeah.
All right, so let's talk about some end-to-end scenarios. So let's actually see how this actually works. Okay, so this is the UI for Chef. So you can see here that I've got all the different machines that I have under management. They're actually machines that I just haven't cleaned out because you noticed that the last check-in was a while ago on most of them. I actually provisioned a machine earlier, so I can see this machine that I just provisioned. And if I drill down into attributes, there's all of those attributes that I talked about earlier. So you can notice that I'm running an Intel CPU. And I can see all of my IP address information and all of that fun data. I can also see what actually happened when that machine got provisioned. So if I go and look at run history, I can see that this machine's checked in a few times. And if I click on this, I can actually see all of the changes that were made to that machine when it came up. So while I'm talking, let's actually go and launch a machine in Azure. So if I go and click New, this is also available in the new portal. I'm using the old portal just out of habit. So I'll click from Gallery, and I'm going to choose Data Center R2. I'm going to give it a name. And, of course, the password of password. Oh. And I just choose all the defaults here. I'll open up HTTP since this is a web server. I'll click Next. So all you need to do now, if I want the Chef extension to be installed, is all I need to do is click Chef. And I'm going to specify a couple configuration bits. So I just have to specify what's called a client RB, and this basically, all this has in it is it shows what Chef server should I be reporting into, okay? So there's just a URL in there. And then I have to have a key to basically let myself subscribe to that Chef organization. So this is basically my pass into the Chef server. And then once I get my pass into the Chef server, I'll create the client. I won't create. The client will create its own key that it will use going forward every time that it talks to the Chef server. And then I just need to specify a run list. And in this case, I'm going to say fourth coffee. and I click Go, and it's going to start launching that machine. So we talked about a couple tools earlier. So you notice I've looked at this earlier. I've got Ignite 1 there. Now if I do knife Azure Server List, so knife is the command line utility for Chef. We have plugins, so we have a plugin for Azure. So it's a fairly easy descriptive language to use on the command line. So it's knife, the object you want to manipulate, and then what you actually want to do to it. The object, or the plugin, the object, and then what you actually want to do to it. So you notice here I could say knife image list, knife server create, server delete, server list, server show, and so forth. So I could do knife server list. And it's going to go out and it's going to query Azure and get my list of servers. Now I could also do this from the Azure command line utilities as well, which is for some reason I think faster. What are you guys doing? Oh. Well, I have no idea what happened there. You can see it worked earlier. Did you go and change something again?
You were trying to say something about Azure Portal, right?
So there you go. So it's actually there. Let me move that up to the top so you can see it. Oh, and look, my command worked over there as well. Now, I can get more information about the machine if I wanted to, so I could just do knife, if I remember how to spell knife, Azure server show, and if I remember how to spell, and it's going to query query Azure and get information back. So if I'm an administrator and I want to find out some basic information, I can get this information back really easily. The other thing that we have is that you can go in here and you can manipulate extensions. So you can also create machines via the Azure CLI. You can also manipulate extensions. So if I do knife VM extension, extension is a really, really hard word for me to spell. I'm not sure why. All right, and then I say Ducey Ignite 1. It's going to actually go and query. I'll actually show you the same thing that's just right above it. It's going to query Azure, and it's going to ask, is the Chef extension installed? So this is in the Azure CLI. You can also do Azure VM extension, and it's going to give you the options that you could actually, so extension list, extension set. So if there's other extensions you want to turn on after you've already launched the instance, you can do it really easily. And as part of, there's a set chef as well. And for set chef, you can actually pass in the key that I just showed earlier, and then also the client configuration file as well. And then you can also specify a run list. And when that extension is added, the run list will actually get executed. So the run list is essentially the chef recipes or roles that you actually want to have executed when chef client runs on the actual node itself.
So whatever Michael has shown with Knife and Azure CLI can also be done with Azure PowerShell as well. So the idea is, we want to support all tools.
Yep.
And based on your comfort level, you can pick any of these tools.
Yeah. Oh, there's some. So the question was, how do you tie it to an Azure subscription? So with Azure CLI, there's like an Azure Connect command.
Yeah, there is an Azure login command,
Yep.
which prompts you to enter your credentials.
Yeah, and then you have a credential file somewhere, a published settings file. And then for Chef, there's actually, I have a configuration file. It's called a knife RB. And in that configuration file, I'd show you, but otherwise, it has like other credentials in there, and I don't want them in the recording for perpetuity. Well, I have to go and revoke them then, and then it's just a pain. But there's a couple variables that you set, and you point to the published setting files that you actually want to use. It's all on the docs page. It'll tell you how to set it up and what variables you need to set in your knife RB. So there's a configuration file called knife RB that knife reads to actually figure out what chef server do I talk to, what are my credentials for Azure, and other configuration information that I might want to use. So, yes? So right now, you can't take an Azure Resource Manager JSON document and then push it up into Azure via Chef. So we're going to add that ability to actually go and do that. We're also thinking about how we can actually turn it more into a programmatic language inside of Chef itself. So you can say, I want this component, I want this component, I want this component, and then translate that into a JSON document. Because the thing, Azure Resource Manager is great, but who likes writing JSON? For the record, no hands went up, right?
I read.
Oh, she like, of course she does. But like JSON's a real pain to write. So like if we can give you some way to take something that's easier to write and transform it into a resource manager template that you could then push up, that would be useful, I think. So you can see the machine that's actually running. We don't have time to actually watch it run, but I actually stood up one earlier, so let's see if it actually works. And you can try on your phones as well. It always takes a while on the first try. So there you go. You can go buy some Chef cookies. So now when I bring that second machine up, that second machine is going to be identically configured to the first. And now I have two web servers that are exactly the same. And then I could go and stand up a load balancer that would then load balance those two machines, right? Or I could put them behind an Azure load balancer as well. So let's take a look at a little bit more inside of Chef. So you notice this is what actually happened. So we saw this recipe earlier. Let me show it to you again. So this is the recipe that I executed. So I install my components. And by components, it's going to actually choose. Let's look at attributes real quick. So you notice I've got install method, and the install method is set to DSC. And then I also have my path as well. So that's where I'm going to actually drop my files in place. Now inside of my recipe, you notice that I use this install method. So what this is actually going to do is it's going to go and execute what's inside of this recipe here. And this is essentially everything that I need to install a web server and the ASP.NET components. So you notice here, I've got the web server, DSC resource, I want to make sure it's present, and then also the .NET bits as well to make sure that those are present. So those will get executed. And then I go back, and then I remove the default site, like we showed earlier, and then just continue on my merry way. So this is what actually happens when I call roll fourth coffee. Yes?
What happens if you have conflicting attributes in the different layers?
Oh, so what happens if there's conflicting attributes in the different layers? So there's a merge order, and there's also precedence as well in that merge order. So the one that wins out is there's automatic attributes, there's default attributes, there's override attributes. You can have attributes inside of recipes. You can have attributes inside of cookbooks. You can have attributes in roles and environments. And there's an order in how those actually end up getting merged. There's 15 different attribute precedents. And so it kind of becomes kind of overwhelming for a new person. So we suggest you take a look at the first 5. And use those first 5. And if you go to our doc site, which we'll show at the end, you can actually find out what that merge order is like.
And if you haven't noticed, Michael is doing this demo with Visual Studio on Linux.
On Mac, yeah. So this is Visual Studio Code. If you haven't heard, they announced that last week at Build. So it's a text editor that they released, and it's pretty cool. There's some features about it. So you notice I'm a horrible Git developer. I'm a horrible developer. It has Git integration as well, so it shows everything that I need to check in. I've got 99 check-ins, and this is one. All right, so this is how it looks, and this is probably still running, but let's just refresh to see that this node actually came up and checked in yet. And then I'll hand it over to you.
Oh, I hope it doesn't fail then.
It's not in yet. But some other things that you can do is, so if I want to see every machine that I ever installed fourth coffee on, I can do a search up here in the console. And I can see, OK, so all of these machines have the role fourth coffee. I could also do things like, if I want name, I could search by name. If I wanted to search by platform, I could say platform Windows. And you notice the search changed, and there's some machines that aren't included anymore. And then that's pretty much it. So over to you, Kandana.
OK. So if we quickly recap what we saw, right? We saw how you can use Chef to write your cookbooks, to write your recipes, to write your cookbooks, and that can manipulate and manage the resources on the VM. We also saw how to provision a single virtual machine instance and bootstrap Chef on that and apply these recipes on that. So now, as in the end-to-end scenario, I want to show you how you can actually provision your entire infrastructure using the templates, the Azure Resource Manager templates, and spin off Chef on each of those virtual machines. So for this demo,
You're up.
I'm already on. Okay,
You're on.
cool. Okay, so for this demo, I want to go to this template repository. This is where we have been publishing the templates that we have authored. If you take a look here, there are actually quite a lot of templates. What I'm going to do is I will search for Chef. Okay, so I have a few Chef templates, and I'll pick a multi-VM Chef template. So what this template does is it can spin off multiple instances of Linux virtual machines and bootstrap Chef on each one of them automatically. So let's take a look at that. Again, this is the preview portal for the Azure portal, if you haven't seen it before. So this is a template. The template is actually coming from GitHub. The template is actually checked into the GitHub public. This is a public repository. You can go look at it. Here, I can edit my template. And all the secret sauce that goes behind setting up these virtual machines and bootstrapping Chef is in this template. So if you look at it, some of the concepts that I've talked about, like these parameterized templates, like, I have parameterized some of the things like, what is going to be my DNS name, the number of instances I want to set up, and a few other, the VM size, where I want to run. And here are the Chef specific parameters. What is the Chef node name? What is my Chef server URL, the client name, run list. Now for Chef server, I could sign up a hosted Chef account, get the URL there, or I could go to Marketplace, spin off my own Chef server, and get the URL here. I will not change anything in the template, but when I instantiate the template, I'm going to give it some parameters. You have to give it a unique storage name, a unique DNS name. So let me know, I'll not type all the parameters, but I want to just show that, I can specify. By default, it is going to create 2 instances. I can specify multiple instances here. And when you come here, there are parameters like the Chef node name, the server URL, and the validation client name. So these are the ones that Michael just showed in the RB file. The same input that he has provided can be provided here as well. Fundamentally, it is the same extension, the same concept, but instead of setting up one single VM, we are setting up multiple virtual machines using a template. So once you enter these parameters and say, okay, this actually takes a little while to create all those virtual machines. So if you go to, and the same thing can be done from the Azure CLI as well. So if I go back and search for Chef again. So this is a single VM example, So these are the parameter it takes. And if you see here, this is the PowerShell commandlet that I can use to create the resource group and the virtual machines. And this is the Azure command line that I can use that uses the same template for provisioning virtual machines. Over to you.
So just a couple more things to help you get started with Chef. So if you're interested in learning more, or if you're like, oh, because there's something already that I could use to maybe deploy SQL Server or manage IIS or something like that. So we have supermarket.chef.io, and if you go there, you can find pre-canned, of course, it's Chef. We have to continue the cooking thing. No one? No? Oh. I thought it was funny. So we have pre-canned cookbooks with ingredients all ready to go for you. So if I search for SQL, you see right at the top, so SQL Server, and this will help me actually install SQL Server. In this case, it's actually 2008 R2. Hopefully it's newer than that, but I could then go and actually download this and then use this to actually go and manage not only the SQL Server client bits, but also the SQL Server server bits as well. You saw the IIS one earlier, but you can find lots of pre-canned things to make it much easier to get started with Chef. So, back to the slides. So, Kandana already showed this, but those are the URLs that you can actually use to get to those. You can also go to the Azure, Marketplace?
Yeah. And
find these templates as well. And then some additional resources for you to actually learn Chef. So learn.chef.io, of course. If you want more information on the Knife Azure plugin, that's the docs URL. So docs.chef.io has all of the documentation that you need. If you search the doc site for Azure, you'll find lots of different resources. If you search for DSC, you'll also find information about using the DSC resource as well. And then Chef Provisioning is where you can get Chef Provisioning Azure. And then the Azure CLI, of course, as well. Also, if you have any questions, if we don't have time to take your questions or you didn't want to ask, come by booth 236. So we're right across from Rackspace and their Airstream trailer. So if you've seen that, we're right next to that, just across the way. And come by and ask any questions. Also pick up some stickers and also some Kung Fu posters, DevOps Kung Fu posters, if you're curious what DevOps is. Yes? Yep. And then additionally, this is your slide.
No, this is not mine. But we have some DevOps resources.
Somebody added a slide that we So some more resources for you as well. And then also, additionally, please evaluate our session.
Yeah, this is the first time we are doing in this format. Please give us feedback on the content, whether it's too deep, too high level, or was it good. We'd love to hear from you.
And thank you very much for attending. We'll be around for a little while if you want to ask questions.